Hello and welcome to Beyond the README. Today we're going to talk about Kubernetes headless services. Headless services are an interesting and probably not often used aspect of Kubernetes networking and service discovery. Kubernetes networking is one of my favorite topics, and I'm looking forward to digging into the details of how headless services work today. First, a little bit of information about my environment in case you want to follow along in your own lab. I'm using K3s single binary Kubernetes on Ubuntu 22.04. K3s is very easy to install. I'd encourage you to check out the project if you want a quick Kubernetes cluster to experiment with, and it's also an excellent production grade cluster for many scenarios and use cases. So today I'll be using version 1.26.3 running on Ubuntu 22.04. You're welcome to use whatever Kubernetes distribution you'd like. Let's take a moment to review some fundamentals of Kubernetes services. I'm going to be talking about services within a cluster today, not load balancer services or ingress or anything that exposes a service externally. Services provide mechanisms for making resources available within a Kubernetes cluster. By default, when a service is created, a single cluster IP is provisioned, and that cluster IP is backed by all of the available pods that serve that service. The kube proxy automatically handles routing traffic to the appropriate backend pod. Additionally, Kubernetes also provides name resolution for the service if you're using a supported DNS service inside of your cluster. In this video, we'll be talking about headless services, which have no cluster IP. So what does that even mean? Well, let's take a deep dive into some of the examples of headless services provided by the Kubernetes documentation. So first, let's take a look at a standard Kubernetes service. I have a simple Nginx deployment definition here that I'll create inside of my cluster. Now with that deployment created, I also have a simple service definition here. Nothing special, just selecting our Nginx app and creating a service that exposes port 80. So I'm going to apply that as well. I can see that my pods are currently being created, so I'll give that a minute to complete. And it looks like my pods are now up and running. If we take a look, we can see we have that Nginx service and a cluster IP address has been provisioned for that service. We can also take a look at the endpoint slice resources that Kubernetes has created for that service. And we can see here that Kubernetes has created a number of endpoints that correspond to the pods that back that service. And we can see some of the IP addresses of those pods are included in the endpoints for that service. We can also take a moment to create a pod and test name resolution from inside of a container. So in this case, my service is named Nginx. So if I perform an ns lookup for nginx.default, which is the namespace for my service, .service.cluster.local, you can see I get the cluster IP for that service back. And again, I can access that service on this address, and the kube proxy will automatically handle translating that address into one of the backing pods for that service. So now we've completed a basic refresher of standard Kubernetes services. I'm going to delete the resources I've created, and we'll talk a bit about headless services. So now let's start discussing headless services. First, let's take a look at the official Kubernetes documentation. And I don't want to read the documentation to you because we're going to discuss and see examples of it in this video, but I would encourage you to read the relevant section of the official documentation for headless services because it does explain exactly what a headless service is, and it explains the different scenarios that we're going to take a look at today. So the official documentation explains a few things. First, it tells us that headless services do not have cluster IPs. Since the services don't have single cluster IP addresses that are handled by kube proxy, they actually return a list of records for the backing pods themselves. Specifically, the documentation defines two distinct scenarios that we're going to take a look at, and it depends on the way you define the service. Defining services with selectors will result in one set of results, and without selectors will result in another set of results. So first, let's talk about the first scenario, using selectors. So if we step back for a second, let's consider what selectors are actually used for in Kubernetes. When we specify a selector on a service, we do that so that service is targeted toward a specific workload, such as a pod. This is what tells Kubernetes about those endpoints that provide the service so that it can automatically create those endpoints as we saw earlier. In the case of a headless service, when we specify a selector, Kubernetes will return A or quad A records in the case of IPv6 for all of the IP addresses that back that service instead of that single cluster IP. So what does that mean? Let's go take a look. Now in this case, I have a service definition that looks exactly like the previous service definition. The only difference is that I am explicitly setting cluster IP to none. So let me recreate my Nginx deployment first, and then I'll create this service, and we'll take a look at the difference. Okay, that service definition is in place, my pods are up and I can see their IP addresses here, and I should also be able to take a look at the service. And I can see my Nginx service has been created as well, but notice that cluster IP is set to none, so there's no single IP address that other pods can access this service with. So what happens if I try to perform a DNS lookup for that service? Well, let's take a look. So I've once again spun up a BusyBox pod, and I'm going to do another DNS lookup for that Nginx service. And now notice that Kubernetes returns the IP addresses for each individual pod. It returns a set of A records for me, and we can see that these IP addresses represent the same IPs that those backing pods are using. So let me go ahead and open another terminal, and we'll delete one of these pods and see what happens. So now I've deleted that pod, and since this is a deployment, of course Kubernetes has already spun up a new pod to replace it. And now if we do another DNS lookup, we can see that the results are slightly different. There's a different IP address in this list, and the previous IP was removed. So in this case, Kubernetes is still keeping track of those endpoints, but instead of returning that single cluster IP address, it returns the IPs for each individual pod when we perform a DNS lookup. And of course, in that case, traffic goes directly to those individual pods. The kube proxy doesn't do any kind of address translation for us. So let's go ahead and delete that service definition and talk about some of the other headless service scenarios. So next, we can talk about the use cases without selectors, where we don't explicitly define which workload that service targets. And there are again two scenarios within the without selectors category. The first is an external name, and that's a type of service that simply creates a CNAME to an external service. That's sort of special. In that case, we'll get back a CNAME record that points at that external service, and we'll see that in action. Any other type created without a selector, create A records or quad A records in the case of IPv6, for any of the service's ready endpoints. So remember that when we specified selectors on our service, Kubernetes took care of creating those endpoint slices and creating those endpoints for us. But you could also create those endpoint slices manually or via some kind of external automated process. This can enable A or quad A resolution for any resources that exist outside of your cluster that Kubernetes doesn't know about, and so it can't target with its automatic endpoint slice creation process. And this is pretty handy. You can have some kind of process that monitors your external environment, automatically creates endpoint slice resources, sets the endpoints ready or not ready depending on whether or not they're ready to service traffic, and Kubernetes can handle returning A or quad A records for you. Some services and some service discovery mechanisms really rely on that resolution of A or quad A records. They can't really handle that cluster IP, single IP concept. And additionally, for resources outside of our cluster where we need to return all of those IP addresses, Kubernetes wouldn't really be able to do that anyway, because those resources exist outside of its domain. The kube proxy can't really handle network address translation in that case. So let's see these two cases in action. So first, let's take a look at this external name. So you'll notice I haven't set cluster IP to none, and that's because you actually can't. It's a violation of an external name service to set cluster IP at all. But by definition, an external name doesn't have a cluster IP. In this case, it simply creates this service named BTR inside of the namespace, and it returns a CNAME to www.beyondtheread.me. So there's no cluster IP address involved at all. This is just a DNS CNAME. And it turns out this concept is really handy because it helps with migrating services into Kubernetes. Imagine you have a database, and the database exists outside of your Kubernetes cluster, but you eventually want to move it into your Kubernetes cluster. You could create the service in Kubernetes with a CNAME that points at that external cluster, and then when you're ready to start moving that service into Kubernetes, it will be easy to transition the workloads to using the Kubernetes-backed database. In that case, no DNS changes are necessary, because you could simply switch from having that service represent an external CNAME to having it represent the actual pods that now live inside of Kubernetes. So let's see this in action. Created my external name service, and now I'll exec into my pod so we can perform a DNS lookup. So now let me go ahead and perform a DNS lookup for that service. And we can see here that I've performed my lookup for BTR. This is the service name inside the cluster, and it's returned the CNAME that I've specified in the external name. So that's a very simple, very useful mechanism that we can use in Kubernetes to make external services available inside of the cluster using standard cluster naming semantics. Now let's take a look at the other case. Now I have a service with the name of Acrotelli, and I've not specified any selectors for this service, but I've set cluster IP to none. So this service isn't going to match any pods that exist inside of our cluster. However, I also have an endpoint slice resource, and in this case, I've set the service name for that endpoint slice equal to the same name as the headless service that I'm creating, a Critelli. And we can see that this endpoint slice defines a couple of endpoints, 2 to be specific. The first one is an IP address that represents an actual web server I have, and the second address is just Google's address for the sake of demonstration. We can see that in the case of my real address, I've set this readiness to true, serving true, and not terminating. In the case of the quad 8 address, I've set ready to false. So let's go ahead and create these resources and see what happens. Create the endpoint slice first, but it doesn't matter what order you create them in. Okay, I've got those resources created in my cluster. Well, let's take a look. So if we take a look at my service, I can see that I have no cluster IP assigned to that a Critelli service. And if I take a look at my endpoint slices, I can see I created that slice manually, and I have 2 endpoints associated with it. So let's go ahead and exec into a pod and see what we get back when we perform a DNS lookup. And I can see performing that NS lookup only gives me back a single IP address. And that's because remember that the headless service will only return the IPs of the ready endpoints. So let's go ahead and modify our endpoint slice and make the other endpoint ready. So I'll go ahead and take this quad 8 address that I have for the sake of demo and set ready to true. And once that's been done, I'll jump back into my pod and perform that NS lookup again. And now I can see that 2 IPs are returned, 1 for each endpoint. So again, this third type of headless service can be really useful when you want to expose a service that exists outside of your Kubernetes cluster. You can have some kind of automation or controller or whatever. Create and modify these endpoint slices and set the endpoints to ready as needed. Meanwhile, the pods inside of your cluster can still use standard cluster DNS semantics to perform lookups on that service. And much like our external name, getting used to these semantics and building them into the pod workflows can be really useful if you're looking to eventually migrate a service into Kubernetes. So thanks for joining me today on Beyond the README to look at headless services. When I first started using these, I kind of found them a bit confusing. Hopefully, by looking at the different scenarios for a headless service, I've given you a better idea of how to actually understand how they work under the hood and what DNS resolution and service discovery looks like to the workloads that leverage those headless services. If you've enjoyed this video, be sure to like it, subscribe, and share with your colleagues. I'd really appreciate it. See you on the next video.